So hi everybody, in this video number 17 in solutions series, we'll be discussing about Nernst distribution law. So it was in the year way back 1872 that two scientists by name Berthelot and Jungle Flesh, however you want to pronounce it. So what they observed was when solutions of iodine in carbon disulfide, that is CS2, okay, were shaken with distilled water. Now, for example, this is your knob. So you have a solution of CS2 here, and iodine is a solute. Okay, so it is iodine in CS2. Now, when you add water to this, okay, when you add water to this, what happens is water and carbon disulfide are immiscible, which means they do not mix at all. So when they do not mix at all. But the fact is that iodine redistributes itself between these two phases, that between CS2 and water. Okay, that's the whole thing about Nernst distribution law. Shaken with distilled water, the iodine distributed itself between the two solvents such that ratio of its concentration in the two layers was constant. So the concentration of iodine in CS2, carbon disulfide, and the concentration of iodine in water. So this, when it is, that is C1 by C2, is constant. Okay. So this is called partition coefficient or distribution. Distribution coefficient. Okay. So this was the observation. So the same thing has been rephrased as has been generalized as Nernst distribution law. So by stating that so this is your Nernst distribution law. So when a solute distributes itself between two immiscible two immiscible solvents in contact each other. There exists a constant ratio of distribution between the two solvents irrespective of any other molecular, irrespective of the total amount of the solute. Okay, this is only one part of Nernst distribution law. If you are asked what is Nernst distribution law, you should mention this, and also what are the conditions under for the validity of this Nernst distribution law. So this is important. Conditions for validity of Nernst distribution law. First, the two liquids are should be mutually immiscible. Solutions should be dilute. All the four must be written, okay, when we are discussing about because each condition is important. Temperature should be held constant. And fourth, existence of similar molecular species in the two phases in contact with each other. Existence of similar species in the two phases. In contact with each other. Okay, and what happens is this is for the this distribution law holds good for the similar molecular species. Okay, so this whole thing holds good. See, when I tell solute, it's not just different forms of solute, it should be for the similar molecular species. This is important. Okay, I will discuss how it is. Okay, so this is your Nernst distribution law. Yeah, thank you.